Well, let's try another example. Let's try to find the interval of convergence and radius of convergence of this power series, which is also centered at 0. So we're looking at the sum from 0 to infinity of minus 1 to the n times x to the n over 2n plus 1. And again, we're going to use the ratio test here because we have our powers of x and we also have minus 1 to the n here. So we look at the limit as n goes to infinity of the absolute value of an plus 1 over the absolute value of an. And when we fill in the details, we get it's the limit as n goes to infinity of the absolute value of minus 1 to the n plus 1 times x to the n plus 1 over 2 times n plus 1 over the absolute value of minus 1 to the n times x to the n over 2n plus 1. Of course, the absolute value of minus 1 to the anything is just 1. And after cancelling the absolute value of x to the n here, we get the limit as n goes to infinity of the absolute value of x times 2n plus 1 over 2n plus 3. And now we're assuming x is fixed, but we haven't specified what it is. But whatever it is, it has nothing to do with the value of n. So we can pull out that absolute value of x from the calculation of the limit, and we get that we're looking at the absolute value of x times the limit as n goes to infinity of 2n plus 1 over 2n plus 3. And of course that's a rational function in n, so the limit is the limit of 2n over 2n, which is just 1. So the limit of the ratio of the absolute value of an plus 1 over the absolute value of an is the absolute value of x. Our ratio test says that our series converges if this limit is less than 1, and it diverges if the limit's greater than 1. So our conclusion is that our series converges if the absolute value of x is less than 1, and it diverges if the absolute value of x is greater than 1. So our radius of convergence here is r equals 1, and to figure out the interval of convergence, we have to check what happens at the endpoints of the interval from minus 1 to 1. So we check each point individually. At x equals 1, we figure out what happens by plugging x equals 1 into the formula for the series. The series becomes the sum from 0 to infinity of minus 1 to the n over 2n plus 1. This is an alternating series. The limit as n goes to infinity of the positive part is 0, and the positive part of the terms of the series is decreasing as n increases. So by the alternating series test, our power series converges when x equals 1. And when x equals minus 1, when we plug that in to our expression for the series, we get the sum from 0 to infinity of 1 over 2n plus 1. And this series diverges by comparison to the harmonic series, the sum of 1 over n, which we know diverges, using a limit comparison test. So we have that limit as n goes to infinity of 1 over 2n plus 1 over 1 over n is 1/2, which is some constant, which is greater than 0, less than infinity, so we can conclude that this series diverges. So our power series diverges when x equals minus 1, and it converges when x equals 1. And therefore our interval of convergence is everything between minus 1 and 1, along with the endpoint 1. So it's the interval from minus 1 to 1, including the endpoint at 1 and excluding the endpoint at minus 1.